let's look at the second example, which is this one. For this one, we have a cosine 10 times cosine 2 theta minus 5 radical 3 equals 0. Here is different now. Here is 2 theta. Okay, now let's see. So step 1 is that we add 5 radical 3 on both sides. We cancel that on the left. So the right-hand side is just 10 cosine 2 theta left. Right-hand side, you have a 0 plus 5 radical 3. That's 5 radical 3. Divided by 10 on both sides. Then 10 cancel each other. So left-hand side has cosine 2 theta. Right-hand side has radical 3 over 2. Okay. So cosine what is radical 3 over 2? Again, think about this ruler. Okay. Cosine is adjacent over hypotenuse. So that's radical 3 over 2. That's 30 degrees, or pi over 6. So 2 theta down here should be pi over 6. Okay, at least you know there is a one solution. So you may put it here, 2 theta equals pi over 6. But remember, you always want to consider in the definition, okay? Look, cosine theta is x. When x is in the first quadrant, using the ruler, you always find out the value in the first quadrant. And then using the unit circle, you then can find out in different quadrant what's going to happen. Down here, you know, here you have a quadrant 4, the x coordinates are the same. You know, x coordinate is cosine, that's radical 3 over 2. Okay, this is very primitive because down here, that's the definition. Radical 3 over 2 is cosine. Okay, it's x coordinate. Y coordinate is 1/2 as sine. So you got another angle, which is pi over 6. And those two on the left are not, because if angles are in quadrant 3 and 4, you have an x coordinate negative. Okay, that's not we needed. Cosine is positive in one quadrant, first quadrant and the fourth quadrant. Negatives in quadrant 2 and 3. So there is another angle in quadrant 4. So then you may write, there is another one, which is negative pi over 6. Again, if you have an angle like this, then you add 2 pi or minus 2 pi, you get another angle. So is the case for negative pi over 6. So don't forget to add the period 2n pi. 2 pi is the period times n. Then you get 2, you get many. Okay, because period, you add 1, you get all different angles. So here, that's why we have n down here. So n can be positive, negative. If n is positive, you go counterclockwise. If n is negative, you go clockwise. Okay. So the solution will be 2 theta equals this one, and 2 theta equals this one. Again, here's 2 theta equals that. If you divide it by 2 to all of them, let me use a pen instead of pencil. Okay, you divide it by 2. Divided by 2, Okay, what you get is theta equals pi over 12. And here 2 divided by 2, so you have n pi. That's the first solution. Okay, maybe the first bunch of the solutions. The second one is negative pi over 12 plus n pi. Okay, n can be positive and negative. It can be 0. If n is 0, what do you get? 0 pi. So that's pi over 12 itself. Okay, so this is the way for 2 theta. You want to find out what's really could be for 2 theta. 2 theta could be pi over 6. Then solve divided by 2. You'll get that. Okay, that's another example. Okay, combining the first 2 examples, you can do many different questions. Let's look at another example. This example says that we have a 5 sine 2x minus pi over 3 equals 5 over 2. That's the given one. You see there is a 5 in front of it, in front of sine. So both sides divided by 5, and then you may cancel this 5 with this 5, this 5 with this 5. Then you have a sine 2x minus pi over 3 on the left. The right hand side, 5 are cancelled, so you have a 1/2 right here. Okay, now 2x minus pi over 3 is 1/2. Then how could this be? We know then there are 2 values. One is pi over 6. Another is 5 pi over 6. Okay, do you remember the first example I showed you? You see down here, sine something is 1/2, then it can be 2 cases, pi over 6 and 5 pi over 6. So here, then this whole thing, this whole quantity, 2x minus 3, can have 2 possibilities. Okay? Yeah, one is the case 1, this case. This case. 2x minus 3 is this one, or this one. Another is 2x minus 3 equals 5 pi over 6 plus 2n pi. It's down here. 5 pi over 6 plus 2n pi. Okay, so there are 2 cases right here. Now, then we solve for x from here. We solve for x. Now, solve for x is easy in this case. Both sides add pi over 3. Pi over 3 on both sides. Okay. And then you cancel pi over 3 on the left. You want to add those 2 together. Here is 6 denominator, so multiplied by 2 on both numerator and denominator. And then and you will have here is 2, and here there is 1 in front of pi. So you have 1 plus 2 is 3. 3 pi over 6. And then you have 2n pi. Left hand side, pi over 3 cancel each other. So you have 2x equals this quantity. 3 pi over 6 plus 2n pi. You still have a 2 on the left. So we want to divide it by 2 on both sides. Okay? Remember, here 2 plus 1 is 3. So 3 over 6 is 1 over 2. Okay? So here one more line would be like this. Okay? So 2x equals pi over 2 plus 2n pi. You still have a 2 here in front of x. We need x instead of 2x. So everywhere divided by 2. Okay, and then 2 cancel each other. So you have x on the left. And 2 times 2 is 4, so pi over 4 plus 2n pi, 2 divided by 2 is 1. 1 times n pi is n pi. Okay, so x equals pi over 4 plus n pi. And then you have n equals that. Can be positive, negative. That's the one solution we get for this possibility. Okay. Now, how about 5 pi over 6 plus 2n pi? And here, again, you want to solve for x. You plus pi over 3 on both sides. You cancel this pi over 3 on the left. Then you have a 2x on the left. And here 2 plus 5 is 7 pi over 6 plus 2n pi. Again, here is 2. All of them divided by 2. So you have x on the left. And here 7 pi over 6 divided by 2 or times 1/2 is 7 pi over 12 plus n pi. Okay, so that's the solution. So you have a 2. One is this bunch, the second bunch is this one. Okay, so here is the important step from here to here. If you want to mark, you may mark. This is case 1, and this is case 2. This value is very important. Pi over 6, 5 pi over 6. And you want to get the whole thing. 2x minus 3 is pi over 6 plus 2n pi. 5 pi over 6 equals this quantity. And here you have to plus 2n pi. Solve it. Do not solve it, then plus 2n pi. You have to put 2n pi here first. Okay? Alright. That's the third example.